All right, we're going to talk about exponential functions. So this is just a review on exponential functions. So if you remember, that is f of x equals a to the x, where our variable now is our exponent. A is greater than 0, so we're not looking at negative values here. That would be a c multiplying out front. And so usually what will happen is we'll have this kind of growth, or we'll have this decay here. Now, this is going to happen when a is greater than 1. So we're going to grow exponentially when a is greater than 1. And we're going to actually get smaller or have decay if a is between 0 and 1. So if it's a fraction less than 1. So when we're talking about exponential functions, we really need to remember all the rules of exponents. So the first thing is if a is greater than 0 and b is greater than 0, then these hold true. Okay, so we want to work on positive numbers. We don't want to deal with negative numbers. We're dealing with positive numbers. So if I have a to the x times a to the y, that's going to be the sum of my exponents. So that's going to give me a x plus y. And if I have division here, a to the x over a to the y, that's going to give me a to the x minus y. If I have a to the x quantity to the y power, now I'm going to multiply my exponents. I'm going to get axy. And if I have ax times bx, that can be rewritten as quantity a times b to the x power. And if I have division, the quotient, ax over bx, that could be equal to the quantity a over b to the x power. So we really need to remember all these rules. A lot of times, this is the one that students get messed up on. They think multiplication, so they end up multiplying our exponents. Remember, we are just adding our exponent in this. Dividing and subtracting. The only time we multiply is if we have a power to a power. So some of the things you're going to have is things like this. 2 to the 5th times 2 to the 8th. Well, that's going to give me 2 to the 5 plus 8, or 2 to the 13th. Most of you will just kind of do that in your head. So you're going to need to remember these. Okay? So exponential growth and decay. Now we're going to talk about this special base called E. E is a very unique base that we use a lot. It is equal, so E is actually the limit as x goes to infinity of 1 plus 1 over x to the x power. We haven't talked a lot about limits yet, and so but understand that this is what we're trying to get at. It's roughly 2.71. It's an irrational number. It goes on forever and ever. So we're going to talk about this, y equals e to the kt, or y equals e to the kx. However you want to write it, it doesn't really matter. So maybe I'll put an x here, since that's what you guys are familiar with. So if we have growth, if k here is greater than 0. So if k is positive, this is going to give me an exponential growth. So it's going to end up coming here and going up towards infinity. Okay? Now I'm going to have decay if k is negative. So I'm going to have decay, or it's going to be coming down towards 0 if k is negative. Okay, so that means as k gets larger and larger, negative, so this would be, as x goes to infinity, this is going to be like negative infinity. So e to the negative infinity is going to get me really, really small. And so we don't have a lot of examples in this. This is a lot of just kind of remembering these formulas and working through it. The one example we're going to talk about is our finance problem. It's y equals principal e to the rt, where p is the principal, r is the rate, and t is time in years. So this is a interest formula here, and what we're going to be looking at is what happens if we invest $100 in 2014 at 5.5% interest. And we want to predict the amount in 2018. So after 2018, how much is going to be in this account? Well, the first thing we need to do is set up our formula, okay? So I'm going to come here, I'm going to go, well, P is equal to 100. R is equal to 5.5%, but we don't write R with percentages. We write it as a decimal. So 0.055. And now I'm going to substitute in. T is my time. It's going to be changing. So I have Y equals 100 e to the 0.055 t. Okay, so this is my formula. This would tell me how much I would make after 5 years, 10 years, 20 years. This would give me the formula how much that $100 is going to be worth. So now it says predict the amount in 2018. So 2018, that gives me 4 years of interest. So my T now is 4. So I'm going to go Y equals 100 e to the 0.055 times 4. Now this is calculator work. So what you're going to do is you're going to plug this in your calculator. So 100 e, let's see, where is it? There it is. So if you're using one of my TI-30s, it's right under the LN button, which is natural log, and it gives you the exponent, 0.055 times 4. And when I get this gives me approximately 124.61 rounded to the nearest cent. So after 4 years, the value in this account is going to be $124.61. So that's a quick review about exponential functions. The biggest thing is remember these rules. These rules are very, very important and we use them a lot.